So good morning, ladies and gentlemen. You are welcome to today's class. I believe you are taking time to go through the lecture notes. I know we've covered quite a few topics, but let me start today's lecture responding to our main question last week. Amit, can you still recollect your question?
Okay, sir.
Yeah.
Good morning, sir.
Good morning.
The question I asked last week was that how can we make, because based on what I've seen, that most machine learning, first of all, is that does machine learning, how will I construct it? Do you have equation for machine learning models? Equation for machine learning models like KNN, ANN that I want to do today now. What is the equation? Like the equation of logistic regression, equation for linear regression. We have equation for that. That after we fit the model, we can make prediction with the model, mathematical expression. So the KNN, does it have its own model? One. Then most of
Is there anyone we have done that we didn't give a model? Yeah, we always give mathematical equation.
mathematical equation.
We've
Like
not done
after
KNN. Today
eh,
we are doing KNN, so you will know about that.
okay, no problem. Like what I'm saying,
KNN is a non-parametric approach, but we'll talk about that when
yes,
we.
sir. Okay, sir. So the second one is prediction. Most
Yeah,
of the prediction have been seeing is always inner prediction, in sample prediction.
yeah.
Like let's say I want to, after I've created a model, now I want to predict for tomorrow's value for price of cryptocurrency. So most of what I've been seeing is always inner. No, I've not seen the one of outside or out sample prediction.
But that's even the one. That's what um, machine learning approach is even meant to do. The first instance. Can you see my screen?
Yes, sir.
So let's say you have data and you have period and you have your y, you have your x, x2, x3, and so on. Now the period can run from 1, 2, 3, 4. Let's even say up to n. So that's the period that you have data for. So in machine learning, uh, so the you already know about uh, 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 the idea of splitting data. So
Yes, sir. So
yeah, so
training. Yes.
we split the data. So if you, for instance, split, then you can have this as your training uh, set, and then you have from 5 to whatever number you have here. Let's even say 50. So, well, I'm just using this as hypothetic. Let's even say 10. So you can have this as your testing uh, sample. So what you normally do is to train your algorithm with this sample. You train your algorithm with this sample. And then after you have trained, you will now, you have your set of Y here.
Yes.
So after you have trained, then you will now use the model and use it to predict y here.
Okay.
Remember, you have the actual y,
Yes, yes, yes.
which you did not use for training.
Yes, sir.
So after predicting the y here, you now evaluate the predictive performance
Yes,
based
sir.
on
The accuracy.
whatever measure of accuracy you want to use.
Yes, sir.
So that is what we call model evaluation.
Okay.
So you evaluate the model in the new data. So this will be regarded as your new data,
Okay.
right?
Yes, sir.
This is the trained data.
Okay, sir.
Now, let's say that that's all the data you have. Let's assume that that's all the data you have.
Yes, sir.
And you now need to, let's say this is n. You now need to predict to a period n plus 1. Let's say this n is 2024. You now want to predict to 2025.
Yes, sir.
Are you with me?
Yes, sir. How about you, sir?
So certainly you won't have data for y because we are not yet in 2025. Are you following me?
Yes, sir. I'm following you, sir.
Let's say y, for instance, is GDP. Since we are not yet in GDP, we're in 2025,
25.
we cannot have the GDP figure.
Okay.
Are you with me?
I'm with you, sir.
So what we will do, let's say this is GDP for different countries. So we can make assumptions about the features, about the explanatory variables. We can make assumptions about them.
Okay.
So, and get value for them. Let's say this is inflation. We can say, well, if we assume that inflation in 2025 is this, maybe it will continue the way it's increasing now. Maybe this is another macro indicator, then you assume. So based on this assumption, right,
Yes.
you can now use your model, the model that you have trained and you have tested, evaluated here,
Yes.
and it has outperformed others. You can
Yes.
now use that model, plug
Okay.
in the assume values for this, and predict this one.
Okay, sir. Okay, sir.
Are you with me now?
I'm with you, sir. Yes.
But there is no way, if you now predict this, there is no way you will be able to know whether your prediction is true or false.
Okay.
Until when we now get to year 2025. Are you
Yes.
with me now?
Yes, sir.
Another example I will give is this. Suppose the prediction we are interested in is classification.
Okay.
And this is not period, but individual. And this is the first person in the class, the second person, the third person. And our Y is to predict whether this student will graduate or not.
Okay.
Are you with me now?
Yes, I'm with you, sir.
And then we have trained the data based on information about those who have graduated and who did not graduate before. And we have tested. Are you with me?
Yes, sir.
Now, we now have a new student who is a new student N+1 that is joining the class.
Okay.
We now want to predict whether this new student will graduate or
Okay.
not. Are you with me now?
I will shoot, sir.
X1 could be the age of the student. X2 could be uh,
The
the gender, the
the
gender
gender.
of the student. X3 could be the score in JAM or
Yes. UTME.
grade, whatever. So we now want to classify this new student. Will this new student graduate or not graduate? So we can easily observe these things on the new student. Is
Yes.
he a male or female? What was the JAM score? And then use our model to say, okay, this new person will graduate or will not graduate. Again, we will not be able to know whether our prediction is true or not until the end of the program.
Yes, sir.
Are you with me now?
Yes, sir. Yes, sir. I'm with you,
And
sir.
then we will be able to say whether our model had
Is
predicted correctly or not.
or
So
not.
this is how the model, machine learning model, and most model, not just machine learning model, that's how they are implemented to predict beyond the
The-
historical period,
Yes, sir. Okay,
the
sir.
period where you have historical data.
Okay, sir. Okay.
Does it make sense to you?
Understood, sir. Yes, sir. Understood now. Thank you, sir.
Yes.
I'm clear now.
I've not seen Dr. Lowoke. He,
Actually, we will
yeah,
soon.
is using, we've done a lot together in that respect. So, is anybody, does anybody still have anything to be clarified? If not, so let's move to what we have today. So today we will be discussing another interesting topic. I'm feeling as if we should just stop here. But uh, I will let you know, at least you have a good number of algorithms to play around with. So there's no algorithm that is not mathematically uh, presented.
Okay, sir.
You will always see the mathematical equations. So they are all statistical model, logistics, discriminant, Bayes. Only that in machine learning, we call them algorithms.
Okay.
And then um, some assumptions are just relaxed because they are used for big data analytics.
Okay.
So today, yes,
One last question, sir. I have, based on what you just said now, does assumption of normality parameters is it applicable in machine learning?
yeah, we always assume that the no matter the parent, the underlying distribution, if the sample size is greater than 30,
Yes, sir.
then it's assumed to be normal.
Yes, sir.
So just a minute. Sorry, I'm back.
Okay, sir. Okay.
Yes, I think you were asking the question.
Yes. Is probability assumption applicable in machine learning?
So I was saying that you use big data.
Yes.
So most assumptions like normality are no likely to be relevant again because you are not dealing with small sample situations. So
Okay.
uh, the central limit theorem uh, has made it clear that
Yes, sir.
regardless of the parent distribution, the underlying distribution, as the sample size becomes
Okay.
large, you know, the,
Which is normal.
yes, so it tends to normality. So we rarely test for that in big data because it's likely to uh,
Be
become,
normal. Okay.
yes.
Okay, sir. Thank you, sir.
Yeah. So for today, we are going to talk about the K nearest neighbor.
Thank
Apart from the lecture notes which I prepare, I've also attached uh, one lecture note I use somewhere, which can also be very helpful. So, but before we use it, let's go through the outline of the topic. So, K nearest neighbor, the plan is to first introduce you to uh, basic definitions and concepts. We won't waste time on that, historical development and so on. You will take time to read all those stuffs. But the algorithm, we need to understand the basic principles behind it, which I will show you in the slides, the Google slides attached. So you will also understand the steps. There are four, the steps are summarized into four. And then there are distance measures which are used. Uh, some are popular, some are less popular. But for academic purpose, it's good you have idea about those metrics. Most critical situation, most crucial aspect of the K nearest is choosing the right K. So it's not automatic. So you need to search for the optimal K. How do we do that? There are a number of uh, options or procedures that you can follow. So here you also have some practical tips that can help you to get the optimal K. The K nearest neighbor algorithm can be used for both classification problem and regression problem. You remember classification problems are problems to predict categories, whether the customer will churn or will not churn, to predict whether the patient will survive or will not survive. So when you are predicting categories, whether it's student will graduate or will not graduate. So those are classification problems. Regression problems, when you are predicting quantitative variable, you are predicting growth rate, you are predicting inflation rate, you are predicting exchange rate and things like that. So KNN can be used to predict, to address classification and regression problems. So how do we go about that? So it's part of what we intend to talk about with examples. And then we'll go to R, particularly, and then for those who have expertise in Python, you can use the Skykit Learn in Python, which is a built-in library for implementation. For R, we have examples or the scripts, but I really didn't run any specific example, but you have the codes and the data that you will run on your own. Then, like any other model, you can evaluate. I've talked about evaluation this morning. So evaluating criteria for classification, they are discussed. Evaluation criteria for regression, they are also discussed. So you have in this session the performance metrics for classification and regression problems. In this section, it talks about the merits and demerits of KNN. By the time we go deep into KNN approach, you will see the simplicity and very limited or even absolutely no assumption situation surrounding it. So here we'll be able to see the advantages and disadvantages. I don't intend to cover all of this, but I will only focus on the important ones. Then the advanced topics in KNN, which will interest you. For those who want to possibly develop interest or research interest in advanced in KNN, you might want to look at some of these advanced topics. They are not really meant for exam purpose, as I always mention for this course, but some of these are put together for my own ultimate objective. Then you have practical applications and case studies, the summary and conclusion. And then you have some very rich references that you can consult for further reading. So before we go to the introduction, I would rather want to use the slide I shared, this slide, to introduce you to the idea of K nearest neighbor. So first, in the slide, you want to know about K nearest neighbor. But other than that, that's the only reason why I'm using this slide. But you can also use the rest of the slides to learn how to run the K nearest neighbor and compute prediction accuracy, and then how you can this actually there was an error there, so there are only two items there, 1 and 2. This third one is a repetition of the second one. So when we talk about the K nearest neighbor technique, one is a non-parametric method. And I know you understand the concept of non-parametric. When we say a technique is non-parametric, we simply means that there is no underlying distributional assumption. Most techniques require that we assume that the underlying distribution is normal, is logistic, is chi-square. So we used to, for parametric techniques, they are developed based on the underlying distribution assumed. But here for K nearest, it doesn't have any of such underlying distributional assumption. So it can be used for both classification and regression. But the most of the times, what people use it for is classification problems. And I've explained that for classification problems, you are predicting category, you are predicting class, group, predicting whether it will go or it will not go, whether it will survive or not survive, whether it will appreciate or depreciate. No, when you are predicting groups, category, then you are talking of classification problem. So the idea is to predict new observation and say, okay, it will belong to this. So new students are coming in now. We could be interested in predicting whether they will graduate, looking at their historical academic performance. We can predict whether they can graduate or not. We can also be interested in predicting whether they are potential autists. So you can do that. So new observation is classified using the KNN approach. But this approach will do the classification based on the closest observation. And I will explain that more. But because it's based on the closest observations, then we say the closest neighbor. So if I want to predict Adjacent now, I will look at his closest neighbor. Whom does he work with or relate with? So I can predict his location. So the principle underlying this is predict me based on my neighbor. I predict you based on your closest neighbor. So that's the principle. So it's believed that your neighbors know. If I know anything about your neighbor, then that can also help me to know something about you. So, but how do you determine neighbor? You have to, you have it. How, as we are all scattered now, who is my neighbor? Some of you are joining from your home and so on. So, who is my neighbor? Distance will be used to determine the neighbor. So, based on the distance, then I can say, okay, this is my nearest neighbor, this is my far neighbor, so on like that. So therefore, distance measures are usually employed to be able to calculate distance to determine neighbors. So neighbors can be near, neighbors can be far, so on. But the K nearest one is what we will focus on. So look at this. In fact, this is one reason why I brought this particular slide. If you look at the screen very well, how many colors can you see of dots? Can you see? How many colors of dots can you see? Mbokubon.
Good morning, sir. The screen I'm seeing is the okay. I'm just now seeing the slide.
What have
Colorless green and red.
what have you been seeing before?
The the one that mirrors your screen, that repeats the screen. It's just now that I'm seeing the slide.
Okay, how many colors of dots can you see there?
3.
Three, what's the first one?
Green,
Green, yes.
gray,
Gray, yes.
and red.
Red, thank you. So our interest now is, look at the gray. The gray will be considered as a new person we don't know where we should classify. We don't know whether we should say it belongs to green or it belongs to red. Blessing,
Yes, sir.
where will you classify the gray?
I will classify it with the green because it's closer to
I can't hear you very well.
I will classify the gray with the green because it's more closer to the green dots.
You're already using the nearest neighbor. How do you know it's closer? By just using your eye.
Yes, sir.
Are you closer to me than Joseph?
No, sir, I'm not, sir.
You are at home, right?
No, sir, I'm inside Lisa lab.
So certainly you are also a neighbor now,
Yes, sir.
but someone is more
Closer.
closer. Yes.
Yes, sir.
So who else is there who has not spoken? Who else is there who has not spoken?
Femi has not spoken, sir.
Femi, you are spoken. We greeted you. So, but now
Okay.
you can speak. You can speak to the issue.
Okay, sir. So, based on what my colleagues have said previously, I will go with them. We have three colors, and the colors have been identified. And the gray color, if we look at it critically, it's more closer to green color. And if we look at that region, if we just try to circle using that gray color as the center, if we can draw a kind of a circle, we'll discover that the circle will cover 4 dots. That it will cover the gray, it will cover 2 green and a red. So using that just picture, we can see that the gray is more closer, it's closer to the green for it to attract 2 greens to itself, so we can classify it to be a green color.
You know my problem with so I think yeah, my problem with those analogies because you have not defined the neighbors. You are on your own. Because if I decide, look at my hand. Look at my hand. If I choose as the neighbors, then this and this will be about the same distance with this. I'm coming. If I choose this now, I choose one green, one red as the neighbor.
Prof,
Yes.
Yes. I don't think we are seeing that demonstration.
You are not able to see it.
I hope I'm correct, guys.
Sir, we are not
Yes, you are correct, sir.
Yeah, we are only seeing that your slide, the KNN. Yes, maybe you were using.
You are able to see this. Okay, what I'm saying is this. Where can I? Let me see if I can select. Okay, let's come here. What I'm saying is this. This is our gray. And then we have this is gray. This is green. This is red. You know we have another green here. What I'm saying is that if I decide to choose this is gray here. I've decided those I consider to be the neighbor. Then the question is, which one is the nearest neighbor? Here I've used only 2 as K, as neighbor to the gray. How will you now be able? The distance between this is approximately, you are just using your eye, no, approximately the same. So you are saying something?
Yes, sir. Yes, sir. So what I was trying to explain the other time is we can kind of assume a distance. So we're just using construction idea, as in the basic construction method we have in our secondary school mathematics. So if we assume a distance, so we can now use that distance as a radius to form a circle using the gray color as the center of that circle. So by the time we have that circle, we'll be able to capture a reasonable number of both the red and the green color. So we can now see, I think from there we can now know those color that are closer to green, I mean to the gray color, if we now measure the distance, sir.
Okay, so the idea is that the starting point is to define who are the neighbors. Who are the neighbors? We can see all the points and consider them as neighbor. In fact, my neighbor could extend to Benin Republic. My neighbor could extend to Niger Republic. But first of all, we need to decide the neighbors. And that's why we will start with the word K. So the K there helps us to define the neighbors. And that's what we try to do here. This time, we have decided to choose the nearest 5 dots as neighbors. The nearest one, the 5 nearest, so to say, the 5 nearest dots to the grade that we want to classify. And so the 5 nearest K that you see here in circle, we have 3 of them that are green, and we have 2 of them that are red. Again, how do we classify? You know, based on this K nearest neighbor. So the point here is that the starting point is to define the K nearest. And here we have chosen the 5 nearest neighbors. So having chosen the 5 nearest neighbor, we will then compute the average distance from the grade point to the green point. So for each of the green, we get the distance, and then we find the average of the 3 distances. For each of the red, we find the distance. Again, we find the average of the distances. I hope what I'm saying is clear. So,
Yes.
Yes, sir.
So we will find the average, and then first of all, we find the distances of each of them. That is the distance from here to this, the distance from here to this, the distance from here to this. Then we have the average of those 3 distances. That will be for green. The distance from this to this, the distance from this to this. So we have 2 distances. Then we find the average. Then we will now assign the gray to the one with the closest or the smallest average, and that is the closest neighbor, right? So if we are to do that, this is what will happen. Let's say we are able to find the average from this to be 4.6, from this to be 3.3, from this to be 3.1. So we find the average of the 3 measures, and that gives 3.7. Then we do the same thing for the red, 5.8, and then 3.5, the average is 4.7. So based on that, we will now assign to the smallest. The smallest is 3.7, and so that observation, that gray observation will be assigned to the green to be the family of the green color. Is that okay?
Yes, sir. But I have a
Yes, sir.
question.
Ask your question.
My question is, in a situation where when we draw the circle, then let's say for the green, we have like 5 green points. Then we have just one red point. But that one red point is very close to the gray than the 5 green points. And since we are taking the average, so that means the average of the green points, which are already 5, is far from the gray than just that one red point that is close to the gray. So does it make the green closer to the gray? Sorry, does it make the red closer to the gray, which is just 1 point?
Yeah, what's the average of 1 point?
The assumption here is that that 1 point is very close. It's like, let's say two.
No, we are talking about the average. So if you have only 1
Two.
point, the average also is that same point.
Yes. Let's say it's just 2. Yes. Let's say it's 2.
So you now compare that average with the other.
Yes.
So you follow this. Yes.
No, my own is, because if we are talking about closest neighbors, shouldn't the number of points that are closer to the gray have more advantage? If we have more neighbors, even though it's a little far from the other one, shouldn't it have more advantage since it is more than just?
No, you are now using a different philosophy to group. It's not about the number of the closest color that we are interested in. It's not about the number of the closest color. In fact, if you look at this now, suppose this pink is even very close to this place. The measure might even be, even though you have only 2 here, the average might be smaller than the previous one, than the green, the average from the green. So you could have fewer with small average, and you could have quite a number, very many with large average. So the classification is based on the average of the distances of the groups from the one to be classified. Yes, are you okay with that?
Yes, sir.
Yeah, so Joseph wants to talk. You can talk from the,
okay, I have a question, and my question is that is it possible we have equal distance, equal average distance? And if
it's possible to have equal average distance.
Yes. If it's possible, what can we use as a criteria to choose the which one is the nearest neighbor?
So it is possible to have equal distance. So what if you have equal distance? Let's say when you have chosen 5 nearest neighbors, you can now increase the number of neighbors to 6. You get my point? You can now increase the number of neighbors to 6 and recompute the average. Certainly, you will now have a clear picture of where to classify. So the point here is that, which is the point being made here, the value of K is important in the K nearest neighbor algorithm. So it determines the prediction accuracy. And the accuracy depends on it. Yes. Somebody raising Badmus.
Good morning, sir. Good morning, sir.
morning.
Good morning, bro. Fine, sir.
Good morning.
Uh,
Yeah.
Based on the example that you just, or the computation that you just did now, and the
Yes.
Mr. Femi point, I could observe that when he expressed his own that when you circle, the number of green that is closer to gray is more than the number of the red. And when you compute also, it's only that green also that we still choose as nearest neighbor. So my question is now this, like, is there possible, because which states that what Mr. Femi used is form of visual expression without any computation, and what you did also, you did some computation and also validate that. Is it possible for us to use visual expression to choose our nearest neighbor? That's the first question, sir. Why
If you
some
use,
question?
let me quickly answer that. It's not going to be objective. It will be highly subjective. Even as you are looking there, we all might be looking at the same thing, but we might be seeing different things. If you look at me now, you might see different things. It's not the way you see me that Peter, Mboko Bonk, Blessing will see me. Some will see me as dark, and others will see me as evil. Some will see me as whatever. So if you base it on what you see, it's not analytical. It's not going to be reproducible. It's not precise. So it has to be based on uh, uh, what can be verified. So and it's just by coincidence that the average for the green is smaller. It doesn't work like that all the times.
Hello, Prof.
You have to do the calculation. Yes, Peter.
Prof, just to add again, because this appears to be a recurring thing. Don't forget that we are dealing with big data. Whatever Prof has done now is for illustration purpose. I wonder how your eye is going to capture terabytes of data. All right, sir.
Thank you, Peter, for bailing me out from the prison that Badmus is trying to.
No, sir, no, sir. Because me, I'll be thinking like, if that's old, does that means that our choice of neighbor will be affected by outliers or extreme value, like extreme points of any of green, either of red?
So, but yeah, whatever you see here, as Peter said, is for demonstration. When you are dealing with very massive data, you can't easily use your eye to judge. So you need algorithm that will quickly do the calculation. But again, the emphasis is that you need to know which K is even what you choose as K. And that is the most difficult thing in this algorithm. We will always be looking for the optimal K, because I've chosen K here. Nothing really suggests that I should choose 5. I could as well make it this way so that I have all these points covered. So I could have K to be, yes, about 13. I could make K to be 13 here. So I can choose K, but we need to choose K that will give the optima. How then do we know the optima? For each K we choose, we need to quickly do the cross validation to see whether the classification is optimal or not. So then Yeah, so in practice, the value of K is identified through cross-validation. So K is the parameter that controls for the biased variance trade-off in our model. A small K will lead to low bias and high variance. We've talked extensively about model complexity, model bias, and model variance. So if K is very small, the bias will be low, but the variance will be high. And that may lead to overfitting. Greater values of K can lead to larger bias, but very low variance, which is underfitting. So the K nearest neighbor works best when you deal with numeric predictors, when you are dealing with predictors that are quantitative. In other words, the features, the explanatory variables, or the independent variables, if they are numeric. So it's strongly advisable to standardize the predictors before you do analysis. Standardizing means to convert them to standard form. So I won't go to this one now, but you could, if you want to reproduce the result here, I can also give you the data. So you can be able to, but I use that lecture for a different purpose. So, but with that background, every other thing I want to, you will see in this lecture notes, I've summarized in that brief lecture. So I've talked about the basic principle, the concept, the steps which require that you determine the number of neighbors. You have to select your K. What will be the value of K you want to choose. So you have to do that using, to get the optimal, to avoid the problem of overfitting or underfitting. You need to use the cross-validation approach to determine the optimal K. Then you need to now calculate the distance of each from the one you want to classify. So distance calculation follows after the K is determined. And then you have to sort the distances from the smallest to the highest, because you are interested in the smallest. Then you will select the nearest neighbor based on the smallest distances that you have calculated. And then you can make your prediction. For classification, you will assign to the group with the smallest, that has the K nearest neighbor. For regression, you will assign to the one with average value of his nearest neighbor. So that's the way it works. And this is a pseudocode for KNN. If you want to write the code yourself, you can just follow from this from these steps. So we will talk about distance measures. There are about 6 or so distance measures that we talk about. The Euclidean distance, which we measure the distance from one point to the other. So we can use the Euclidean distance measure. So this is, we are measuring distance from P1 to P, P2 to P, P3 to P. So the Euclidean distance measure has the formula that you see there. So I'm sure most of you have come across this in your mathematics. So you have to sum the square of all the distances and find the square root. The Manhattan distance involves you summing up the absolute value of the distances. The Minkowski distance, we take the pth root of the sum of the absolute value raised to power p of the distances. Of course, when p is equals to 1, the Minkowski distance will collapse and become the Manhattan distance. Let me quickly make some. Okay. So, yes, I was saying that when p equals to 1, Minkowski distance will be equivalent to Manhattan distance. And if p is equals to 2, it is equivalent to the Euclidean distance. Other distance measures include the cosine similarity, and this is the expression. Hamming distance, this is the expression. All of these, they are just for you to note, but most popular one being used is the Euclidean distance or Manhattan distance. This is the most widely used, but you need to know about others. So after computing the distance, you know the next step is to according to the steps listed, is to sort the distances, select the k nearest neighbors. Now, choosing the right k is very important. It's crucial because it determines the performance of the algorithm. So, selecting the right k will ensure a balance between bias and variance. In other words, it will guarantee optimal model performance. If you have small k, I've said it earlier, if the k is very small, then it can lead to overfitting. The variance will be high, but the bias will be small. That leads to overfitting. If you also choose large K, then that could lead to underfitting. The bias will be high, the variance will be small. So you need something between small and large, and that's the optimal K. So overfitting, we've talked extensively about what it means. Then how do you choose the optimal K? Using the cross-validation techniques. So you can use the K-fold cross-validation. We've discussed that. You can use the leave one out cross-validation. We have also discussed that. Again, we have the stratified K-fold cross-validation, which you can use. But there are tips, very important tips you need to be mindful when you are selecting your K. If you are completely blank as to what you should start with, a rule of thumb is to just look at how many observations you have and take the square root of the number of observations, the number of data points you have. So if you have 1,000 data points, just take the square root of that number and approximate it to the nearest whole number. Use that as your K. Some people do that as a good starting point, and then you can fine-tune it through cross-validation. Some people also consider odd versus even. If you are dealing with binary classification problems, for instance, where you want to classify only two groups, groups maybe default or will not default, that's binary classification. Graduate or not graduate, that's binary classification. Where you have this kind of problems, binary classification problems, you choose an odd value of K to avoid ties in your voting. So let your K be odd. But if you are dealing with multi-class classification, where you have to classify into 3 or more groups, whether the exchange rate will depreciate, will remain the same, we appreciate, that's 3 levels. Then you can choose K to be even. So you can consider even value. Another tip is to always perform your cross-validation. We've talked about different techniques for cross-validation. So you should always evaluate different values of K using the CV cross-validation. So it helps you a lot to minimize the error on the validation test. Another approach is to plot the error that you obtain versus the K that you compute. I think I have something like that here. In this analysis, we were able to plot, yes, so this is K, for instance, versus the, so we were plotting the K when K was choosing to be 1, 2. This is the computed error. So initially, when we increased the K, the error was coming down, becoming very small. So this was where we had the smallest error. I think this is about 22 or so. It even got to a point when we increased the error, the K, the error started increasing again. It was not coming down. So one way to always check is to look at the plot of the error versus K. That will help you to know what value of K you have the smallest error. I hope I'm communicating very well. You can also consider computational efficiency, when you are choosing your K, because larger values of K makes your computation to be complex. So you can balance complexity or computational efficiency with performance. You can also use your domain knowledge as an expert, an authority to guide your choice of K. For example, in certain applications, the nature of the data you have may even suggest what should be the range of the K you should use. So combine your intuition with your theoretical knowledge to determine the value of K. So those are practical steps to follow. So how do we employ the KNN for classification? It's the same step that we mentioned earlier. You have to determine the number of neighbors, calculate the distance, sort the distance, select the neighbor, you choose the majority voting, will determine the class, and then the prediction is made. We have example. You can go through this example. Let me correct what I have seen here. Okay, so we have we have example of no, it is not done yet. So Yes. So let's just look at these examples. The first one is the idea of using KNN for handwritten recognition. So you can even do this, collect this data set, you know, of images of handwritten digits, maybe you have data set consists of images of handwritten digits, people writing 0, 1, 2 to 9, each label with its corresponding digits 0 to 9. So if you now have a new unseen digit image and you now want to recognize the handwriting, so you can use the KNN approach. So the algorithm will calculate the distance between the new image and all the images in the training set. It will select the closest image, then the majority digit label among the K images will then be used to predict what the digit is, whether 0, 1, 2 to 9. If that is not clear, another example is a medical diagnosis. You can use KNN to predict whether a patient has a disease, certain disease, if you are given the medical history and test results. So the data you will need will be the patient's records, which will include symptoms, test results, and diagnosis. That will be the data that you will need. And then you can train the model, and you can now use the KNN to do the prediction. Yes. So, and there are several other practical situations where you can use the KNN.
Hello, Prof. I just wanted
Yes.
briefly to show them an image.
Okay, great.
So regarding the okay, sir.
Let me stop sharing so that you can share.
Just briefly, sir.
You can share it. I'm almost through. Maybe I will even allow you. So yes, so you can share now.
Okay, sir. So I just wanted to talk about that. Handwriting recognition is a very popular data set, and I just wanted them to see that. I don't know if my screen is up.
It's up now.
Yeah, it's
Yes,
up.
yes. So this data set is for handwriting recognition. So you have a large data set of different, writings of the digits 0 to 9. And if you can look at them closely and you just figure out a particular, look at this. I don't know if you can see my cursor. Can you see my cursor?
Yes, sir. On
Yes,
6.
sir, on 6.
So if not that this was under the column of it will be difficult to say. Except you have
Femi,
trained,
your mic, Femi.
except you have trained the model very well with a large set of data. Look at another 6 here. Look at this 4. So by exposing your data set to several, images, is able to select the neighbor that is nearest. Thank you, Prof.
Thank you very much. So
I've stopped sharing.
thank you very much. So everything seemed to have been said. What we need now is to be able to do some. So I'll be rounding up very soon. But how do you demonstrate the? How do you practicalize this? So you are going to do it on your own, or you can do it in the class together. One, I'm going to give you this data, and you will go to your R, and you will reproduce these results exactly, and you will be able to interpret. So that's what you will do now. In addition to that, you already have some other useful KNN syntax or R codes that you can use. I have example in this note. I use the iris example, which you can also use, and you have, though I didn't produce the result, but you can reproduce the result yourself and discuss. But beyond that, let me, since I've already shared this, let me share the data, and then you will be able to use it also. Is that okay, class?
Okay, thank you, sir. It's okay, sir.
So you can reproduce the data, just follow the
Codes.
the code here, and then you can discuss the data. So let me include the data. So the data is now added to the material here. So if you follow this, you will be able to read the data and possibly remove missing values, if any. And then you can see the first 6 data, which has tenor. That's the data is about information about telephone owners, how long they have been with the network. That's the tenor. Some have been there 13 years, 11 years, 68 years, 33 years. The age of the customer, the income, the education, and then whether the customer, maybe the members of family, the number of people in the family of the customer. And then this is the variable of interest. What we want to predict is whether the customer will churn or not churn. So this first customer has been with the network for 13 years. The age is 44. The income is 64. The education by where it is ranked is 4. 2 members in family, and this person, if it has churned, then it's 1. So this person churned. So you can now also use the KNN, but before you do that, you prepare the data, standardize the predictors. The numeric predictors are the tenure, the age, the income. So you standardize that. That's what is done here using the scale function. Again, you put the standardized into the data. So you have data now with standardized form. So I leave this to you to go through, and then you'll be able to look at measures of accuracy. This is one measure. So this is able to predict 74% cases, and so on and so forth. This tells you here how you can get the optimal K. So you follow this to determine the optimal K. In our case, the optimal K is 22, and that's what you get here. After plotting the different case against the error. So I leave that to you to do. Finally, there are different measures for prediction. You are already familiar with all of this: accuracy, precision, recall, F1 score. That's for classification. For regression, you have the mean absolute error, mean square error, root mean square error, and all of that. So you can also calculate them using these 2 libraries, the PROC library and the correct libraries. These are the pros and cons of the KNN. So I think I need to, yes. Also. Sorry, just to clean up few things now that I managed to detect them. Okay, so look tidy now. So the advantages, as I mentioned earlier, simplicity, no assumption about data distribution. So that's why it's non-parametric. Then it's flexible. You can adapt it to different kinds of data, quantitative or qualitative. But there are also few disadvantages. The computational process can be very complex. Then it can be very sensitive, particularly if you have features or independent variables that are not even important in the data. Again, very sensitive to, yes, I think this is a, yeah. So it can be sensitive to relevant features. And then it can also be a cause to damage.
Hello.
I think his network went off.
Yes, I also think so. Yeah. So let's just wait briefly.
Uh, Mr. Peter, sir, before he arrived, can I quickly ask a very simple question, though not majorly on this class, sir?
We can't hear you again. What do we do, sir?
What do we do, sir? I think
Okay. All right. Okay. All right, sir. Yeah, Femi, go on. Prof has lost
lost
connection.
connection.
He wants us
He wants
to
us to
continue until
continue
he's able to
until he's
join.
able
Go
to
on.
join. Go on. Oh, okay, sir. So I was at an event yesterday and we're having some deliberation, and one of the most important challenge we have in Nigeria today is our data system. I mean, our data bank. Most time we have to run to World Bank or other banks to get data. So I want to ask, if someone wants to solve that problem, how can one venture into that? I mean, get that data, relevant data, and it should be trustworthy and people can make use. So how can you set up a system whereby you have a reliable data base for people to access?
Yeah,
Yeah.
that's a difficult one because I might not be able to answer as Prof would have, but I'm going to give it a shot. Can you see my screen?
Yes, we can.
Yeah, so I'll just what material were we using? Let me just go to that material. I heard your question. I'm going to say a bit I can, and I'm sure there are more people in class that can talk to us about that. So sometimes it's not about even getting the data. It's even about whether the data is reliable. There's so much of false data out there. Okay. So it's a complex problem. But do you know also that information could also help? We don't have a data collection lifestyle in this part of the world. I wish Prof was here. He told me about, maybe me and us somehow, about the way he has been collecting the data concerning his expenditure. I also know that at the LISA lab, the interns there, maybe not this set, have been mandated to start collecting data on food prices. Okay. Yesterday I was watching a program, and I saw that a basket of tomatoes, which used to cost 50,000 naira sometime last year, is now about 150,000 naira. That's a serious source of concern. In addition to that, we had a lecture 2 days ago with some of us here, and we really emphasize this point. Prof also has a program that he holds on Thursday. Okay, so those are the kind of interventions that can begin to help us to collect data. Do you understand? So I don't think there's a one size fits it all. It's a problem that we have when we want to also do research. But I'm even bothered about when you even get the data. What's the integrity? I don't know if I've said anything. Have I said
Yes,
anything?
you have said something. So now my major concern now is how to address this problem at the grassroots. That is, can can we have a body, a kind of a private body that can just okay, if we have someone that want to solve this problem of collecting data and pushing it out for people, as in you want to be the source
Yes,
of that data.
yes.
How
We have
can one go about it?
there's a solution already, and the passion with which you are speaking, I will only add to that solution. Prof is already running a program. I'm sure at the back of his mind, that's part of what he wants to do with that Thursday program. So apart from asking you, encouraging you to, share these thoughts of yours with him, maybe that are you planning? Okay, you're in your second semester. Maybe that could be something you work on your thesis, your project. That should be, because the passion with which you are saying it is infectious. Don't infect me with this passion. You know what? I want to finish this document, and then if we have more time, we can still allow other people to talk about it. Okay, Femi. Femi. Hello. Femi has run
Yes,
away.
sir. Yeah, I'm here.
Yeah.
I'm with you. Thank you,
Okay,
sir.
okay, okay. Okay, so let's just run through this. And if Prof comes, he will interrupt me. And then if you see him in class, let me know. I'm not able to monitor. Oh, Prof
Prof,
is
but
here.
now you can continue, Peter.
Okay, Prof. All
Don't
right,
worry.
sir.
So you close the class when the
Okay, Prof.
time is up.
Okay, Prof. Prof, don't go yet, sir.
Okay,
Can
you
you?
have something to give
Like
me.
3 minutes. Yes, I have problem to give to you. So Femi was complaining about the problem of getting data. I'll give him 1 minute to ask his question, and maybe you can bless us with 2 minutes. Femo, go
Thank
on.
you, sir. So, Prof, sir, I was at an event yesterday, and most starters and corporate organizations were complaining that the issue of data in this side of the world is so alarming, and we don't have a good data collection system and data bank unlike other developed countries. Now, my question is now, how can we solve this problem if someone like me actually want to, okay, I want to be the solution to that by gathering data and supplying it to people to use? How can one go about it, sir? Thank you, sir.
Yes, so um, data is becoming, it's a commodity now. Just like any product in the market, and you can put a price tag on data. You can even publish data without even analyzing it. So data is a product which is marketable. So you can, but there are, those who are doing 758, we talk of official statistics. Those are data produced by government. There are also data produced by individual business organizations. We are using Google Meet, for instance. We are generating data for Google. They may hide our identity to protect us, but sometimes also they sell our data to those who make advertisements. I'm sure you have received a number of unsolicited emails, and you wonder how they got your email. So some of the apps that you submit your details to, they share your email, your information with marketing organizations. So the point is that yes, you can be a solution to the data blank situation that we have currently. If you choose what aspect you want to collect data. SDG is a global thing. They need more data at the local level. For instance, if you are living in a community, you can be collecting information about households in that community, how many family, each housing unit there, how many family live there, how many children, how many aged, and so on. If you have an idea about businesses, occupation, you can have data on maybe their energy usage, maybe their the utilities available, what type of water they use, where the amount of water they use. So you can also go into climate-related issue. People want to know if you are collecting data about rainfall patterns in Ibadan, for instance, or in your location, and you keep that record. Personally, I keep a number of records. Just all my medical records, I have asked my to give me. I have quite a number. I even want to analyze them now. So you can also be keeping your own health record, your financial record. Anytime I go to supermarket now, I collect my receipt. When I come home, I have a survey monitor, price monitors survey that I developed for myself. I monitor the prices. One spectacular one was this seaway water we used to buy. At a point, I was buying it 800. If I started around 750 or so, then it grew to 800, 1,000. Now we are buying a refill for 1,500 or thereabout. So if you keep that record, you keep, everybody keeps, we can aggregate and have a very massive data set. So, of course, you can venture into data gathering, but you now need to know what type of data you want, and then who are the potential users of that data: investors, government, individual researchers, and so on. If you are collecting data that students will need for their research project, they can come to you and buy the data. Dr. Olowekere is not here now. He's into data. He has a very massive data repository, and is able to use it to make a lot of, I don't want to say fortune. So, yeah, you can go there. More so with your knowledge. All of you should not even be suffering for lack of anything. You should be with your knowledge about data. You should be swimming in. You will ask me, am I also swimming? No, I'm not swimming in money, but you have opportunity to really be an entrepreneur and add value, turn data to money. Does that help you, Femi?
Yes, it really does. Actually, the conference yesterday was on SDG and climate. So
Great.
there are a lot of data gap in that arena. So not just to waste our time, possibly after exam, we still come and check on you, sir, and because it's a whole lot. SDG in itself, it's very, very wide and big. Even climate change itself, it's very wide and big. So getting data for all those information, those indicators and all that is very important. So thank you so much
You
for
have
the
to,
information. I
people
will
will need
see you
to,
later, sir.
you
Thank you,
will
sir.
not be able to get the data. No problem. There can be collaboration to generate this data. But if you don't say you will get the data anywhere, you are not likely going to get it anywhere. But you can see it as a gap. And in life, what you normally look for is a gap, opportunity, something, a green area, a fertile area that when you feel it, you make a lot of fortune before that started messing it up. So it's a good area that you can go into. Peter, I think I'm done.
Please, sir, before you leave, I have a request.
Okay.
Just in case we don't meet up before exam starts, sir, can we have other algorithms if it's available uploaded on the platform so we can read through?
When I finish with my book, you will get everything.
Okay, sir.
Mbokobon, you are getting it for free now. When I turn everything to book, you will need to pay. You comment. You will need to pay. Are you not going to pay?
I will pay.
It is even compulsory that all of us must buy. It's compulsory.
It's not compulsory. It's not meant to.
No, no,
Guys, I'm fine now.
I don't make anything compulsory. But you can buy to encourage. And when you do your own too, people will buy. But if you don't buy my own, you do your own, nobody will buy. So Peter.
Okay.
Thank you very much.
Last thing, Mbokobong, you
No,
wanted
I was only going to say I just hope it will be student friendly. So at least we won't have. I said I hope it will be student friendly. The price will be friendly.
Don't go that way. I mean, most of you, if you look at the wristwatch you are using, the phone you are using, are they made for students? Are there student wristwatches? Are there student phone?
Some of us don't use wristwatch.
But when
Some
it
of us
comes
don't
to
have
book,
wristwatch.
when it comes to book, you ask for student price. Knowledge is You don't price it. You just pay for it and go away. Okay, Peter, you have continue.
Thank you, Prof. And thank you, everyone. We don't have much time, again, but let's see what we'll be able to do. If you can see my screen, let me know. We are just going to browse through. Please let me know.
Yes, we can see your screen now, sir.
Okay, so let me just take us a step back and then run through like 10 minutes, and then we round up the class. So Prof introduced us to some advanced topics, one of which is weighted KNN. So we expect that that could be an area where you can, do your thesis. There is handling missing values. And he has given us this example code, which I see as something very useful. You can just copy and run it on your system. And if it doesn't run, you can check the error output and then debug it. The library used here is DMWR. And mind you, this code is written in R. Please note that the number of points is measured there. And that's the major thing with the k nearest neighbor method. You have to determine the value of k. And he also showed us different approaches by which you can get k. Because if you don't define your k well, at the end of the day, the prediction might be skewed to one way or the other. So we talked about scaling and normalizing data. And just to help Amit, you would have noticed that we've used functions today to use equations, we've used mathematical representation. And it's so refreshing to know that machine learning is also statistical learning. So those functions and equations that are used in statistics are also carried over to machine learning. Feature selection and dimensionality reduction is something that we looked at when we were looking at the regression models. After doing lasso, partially square, and all those, we talked about principal component analysis and dimensionality reduction. So these topics actually are things that you need to look at as tools for, writing your own research. So I don't know if you have seen this, but practical application and case studies. It's important to note that just like the naive Bayes we did last time, you can also use the KNN neighbor to solve the same kinds of problems. It is just the structure of the data that now can guide you towards which algorithm is best, or by the time you use several, you can now, compare. So we see that in real world application, we have recommender system, and that's what one of the things that Prof used to respond to Femi's question is that we are using Google applications and we are providing them information, and that's why you find some things that you did not ask for and they recommend. And sometimes they could be very, interesting to you, and you wonder, how did they know? How did YouTube recommend this video? It's still using the data that you have provided, not just by answering questions, but by being online. Okay, so your activities online are analyzed, and then similar products are recommended. KNN neighbor, simple. Okay, so we talked about test classification. So at the end of the day, fraud detection, spam detection are good examples of how KNN neighbor can be used. Permit me to give you an example in one of those lessons that I got. So there is this phrase, Nigerian prince. So in one of the tutorials, it was like, it's easier to know that an email can be categorized as spam if you find that phrase Nigerian prince. What it means is that a lot of fraudulent mails have been analyzed, and some of the terminology or keywords that were found were keywords like Nigeria and prince, sometimes coming together. So by the time you see those, keywords, and you are now using KNN classification and not regression, it's easier to classify that mail as fraudulent or otherwise. Okay, so you have anomality detection, you have customer segmentation, and then Prof wants us to go, oh, wow. He wants us to go on and begin to look at those case studies. Where are we now? I think we're on page 19. By the way, it's important to know these expressions: accuracy, precision, recall, F1 score, mean absolute error. Not just know their expressions in terms of formula, but to be able to solve problems on them. Recall is the same thing as sensitivity. Know the definition, know the expression, be able to compute them. Very important. Same thing with mean absolute error and mean squared error, RMSE. They are critical. My people, they are important too. Okay. So where do we go next? Where are we now? Let me just run down to where I think we should end the class, because I think I saw something that we should end with. Yes, this is what we should end with.
Good morning, Mr. Peter.
Good morning, Soji. How are you? Did I get your voice?
Yeah. Very well, sir. Yeah. I would like you to speak more on the fact that KNN can be used as for regression and classification. So I've always thought about KNN as a classification model. So how do I? Please, can you just give us a real life application in terms of?
Okay, so what one would do is just to not just to speak about KNN, but to just speak about supervised learning, and then I will fit in KNN, okay? And it won't take more than a minute or there. Okay, so supervised learning is about having data that is already labeled. You already have an idea of what the output looks like. And what you are trying to do is to predict, to see if your model is able to get an accurate prediction. So in trying to predict, there are two things you can predict, so to say. You can predict a point, a value, a number, a numeric continuous point, but you can also not predict a specific value, but rather predict a class. Therefore, supervised learning remember, supervised learning is about labeled output. You have an idea of what you are trying to predict. So it's either you are trying to categorize in the sense of classifying, or you are trying to predict a particular value. So if you want to get the inflation rate for tomorrow, a specific value, you say it's regression. If you want to determine whether it will be higher tomorrow or lower, it's classification. So when you have your data, the kind of prediction that you are going to make, whether it is numerical or categorical, is what determines whether you are using classifiers or regressors. So what you do when you fit a model is that you first call the function, that is the kind of model that you want to use. So, for instance, SDM, support vector machine, started as a classification algorithm. But because it also has the ability to predict specific values, we now have support vector regression. In the same way, decision tree started off as a classifier, but because you are also able to predict specific values, it now became, it can also be called decision tree regression, or decision tree classifier. So for KNN, in these instances that we are looking at, even on the screen, you can see that in points number 4 and 5. Can you see my screen? I don't know if you can see my screen. If yes, good. So we have KNN for class. Yeah, good. So we have KNN for classification and we have KNN for regression. So it says KNN is widely used for classification tasks, leveraging the majority votes of the nearest neighbors to assign class labels. So if you want to use it as a classifier, you now like benchmark, you find your K values, and at the end of the day, you choose the one that has a majority. And that's why we're using different methods like the Euclidean expression, the similarity, cosine similarity scores, and all of those things that we use. So what am I saying? What I'm saying is, if you are going to predict a continuous target, then you use KNN for regression. If you are going to predict a class, then you use your KNN classification. So if I want to use spam detection and I want to use KNN, would that be classification or regression? Soji?
Classification, sir.
If I want to predict oil price and I have, oil prices values, would that be classification or regression?
Regression.
So a lot depends on the data itself. And that's why I started by saying this is all about supervised learning, where you already have an idea of what the output looks like. Unlike unsupervised learning, when you don't even, have the labels of the output, and all you need to do is to now begin to look for patterns, look for structures that are similar, and then you aggregate them together. And that's why it's called clustering. Okay, usually. So you have hierarchical clustering and all those clustering algorithms. However, in modern machine learning, the aggregate of the two is now being used. That is a combination of both supervised and unsupervised. And some people call it semi-supervised learning. Okay, and if we take that as our title, it means that for a part of the training, you will use supervised learning, and at another level, you use unsupervised learning. I don't know if I've answered your question, but the summary of the answer is that whenever you are predicting a specific point, then you refer to regressors. But when you are classifying or when you are categorizing, you use classification algorithms. So a lot depends on the kind of prediction that you are trying to make. So, implementation of KNN, let's just finish here. Both built-in libraries and custom implementation were discussed, demonstrating how to apply KNN in R for various data sets. What that means is that whether you are doing classification or regression, specific libraries that are used will now be redefined according to the structure of the data. Lastly, before we go, if there's any question, future directions in research areas. You can look at this closely and ask yourself, would I want to do my research in this area? Or do I want to add to the robustness of this model? Then you can now begin to look at all of this. We do not have enough time to say more, but thank you for coming. And please make sure you look at these materials again. They are very lovely materials. You can go to Kaggle, materials such as Towards Data Science, Coursera, and they make a lot of difference. When you are subscribed to these things and you read them, it helps you to work better. Any contributions? Antione, you want to make a comment? Okay. She's not here. Good evening. On behalf of Prof, I say good morning to you all.
Good morning, sir.
All right. Yeah, Emo, let's also talk with this one that you want to solve. this problem. It's a good thing.
Yes, so we need to solve a lot of problems.
All right, thank you. And then maybe we'll now go to Prof together. Or you see him and we see him together. We have to solve the problem.
Yes.
Or you see him and we see him together. All right. God bless you.
Yes, sir. Yes, sir.
All right. Thank you. God bless you.
Amen, sir. Thanks, sir.